Sorry about that.
No
All right.
worries.
So let's see. So hopefully everybody can see the presentation. So I know in the past, I guess at the beginning of May was kind of when the Geomad product was introduced. And it's now available on the Sandbox. After the transition's taken place, it's now one of the products you can access. And I just wanted to kind of clarify, I think there might have been a little bit of confusion between what is a Geomedian, what is a Geomad, and kind of understanding the relationship between the two, I think is important. So that's what I kind of wanted to dive into. This slide should be familiar. This is a quick review of a Geomedian. And the idea is that for each pixel, we have multiple observations, and this pixel may change color, right? And so remember, we're trying to think about one of the kind of like higher dimensional spaces. And so for each pixel in the image, we have multiple observations. And what we would like to do is that we may not have an observation for this pixel for each point in the time series, right? As we're capturing our images through time, we may have to mask out some of the data because of clouds, because of snow, because maybe there was a problem with the observation, whatnot. And what we would like to do is try to combine all of these observations into kind of a representative observation. And the geometric median is a way to do that. What we do is we invent a point that minimizes the distance to all the other observations. So we basically say, what color should this pixel be? It should be a color which minimizes the distance to all the other color, all the other colors it has been. And this can be kind of complicated because, you know, we're not dealing with just red, green, or blue. So, you know, for instance, with Sentinel, we can have 10 different bands, and it's important that we preserve the relationship between the bands. So that's kind of what this infographic represents. I'll let y'all look at that. I'll distribute this afterwards. So the main reason why geometric medians are useful is they let us to take many imperfect observations and combine them together into kind of a nice representative observation that we can then still do band math on, and it still kind of means something. Are there any questions about what a geomedian is or how you get it?
I think you'll be able to share the slides with us.
Okay. All right. So now so this is actually a notebook from one of the workshops that's done, but it's also just like available from the, if you go to the Digital Earth Africa actual documentation, there's also a link to it there. But I'm gonna try to put this in WhatsApp right now. Let's see. Okay, so cancel, send. Okay, so I think everybody should see. That is actually, I don't know if this is convenient for y'all, but at least it's in the WhatsApp. If you want to, you can go ahead and download that small notebook and upload it to the Sandbox. And I'm going to share my screen as I run it.
Brian, while you're doing that, would you mind also sharing the presentation on WhatsApp in case that anybody is falling behind?
Yeah, I need to export that to a PDF, so that'll be a bit more doing.
It's fine. So
yeah. 1 second. So yeah, if you have any questions about running, creating the Geomedian, there's the generating Geomedian composites, which is a really useful notebook, which is just where I pulled those pictures from. It's the default example. And then what we have is that it'll look a little strange the first time you run this. But what you should do is go through and run each cell and then start adjusting the red, green, and blue for each one of these values. And so the idea here is that this would be our first time step, this would be our second time step, and our third time step, right? And we can see these points. This would be the idea is that if we only have like 3 bands, right? That let's say we're only looking at kind of the red, green, and blue, but this could be, you know, many more different bands, you know, such as like SWIR, near, or something like that. And we can see that our 3 different time steps are actually graphed here in 3 dimensions. And then what it's doing is it's actually calculating the geometric median and the median for us on the fly. So as I adjust this, right, my third point actually moves around, and we can actually see the difference between the geomedian here on the right and the median here on the left. And we can see them represented spatially down here on the bottom right. And so this, I would ask you to kind of play around with this, see kind of how this works, and you might be able to develop a little bit better of an understanding of what a geomedian is, and how sometimes the median is the same thing, is very close to being the same thing as the geomedian, but in other for other types of observations, they can actually diverge quite substantially. So I think that may.
So Brian, in layman's terms, would it be accurate to say
Yes.
it's a much more accurate way of generating an average, even though it's not an average? I realize it's a median.
No, I mean, a median is a type of average, right? It is a more accurate way of generating an average in higher dimensions.
And the color
and
higher
yes.
dimensions, and you're demonstrating RGB, but we're actually doing this in all the bands, right? In all the 6, 7, 8 dimensions of
Right. Yeah. When we calculate these in our own data sets, we may only have like 2 or 3, but we could have like 4 or 5, right? If we had RGB, SWIR, and near, right? It'd be important to preserve the relationship between those bands, because when we go to do some sort of band map, like in DVI, right? We want the relationship between the bands to be roughly the same as they were for the many observations. And the problem is that if we calculate the median of each channel independently and use that as a representative, right, that can actually skew the color, right? And so it's important if we're going to do band math, it's very helpful to do the geomedian rather than the median. Any questions? I hope, hopefully, if you're having trouble running this, please let me know, but try to, you should just be able to drag and drop and upload that to the sandbox and run it right.
For Brian?
This was part of this was a supplementary notebook material that was actually in the workshops that were conducted, but it's also available. So like, I think let me,
yeah, when you run it, it's like you have to play with the sliders to get.
You have to play with the sliders. It's a little weird in that way.
Broken and then.
Yeah, hold on. Let me post the. Let me see if I can find the link here. So if you go to training.digitalearthafrica.com, like there's some documentation, and you can also find the link there. I'll have to dig it up later. Okay, so I think we had. Okay, you found the link. Thank you. Okay. All right.
Yeah, I found the link too.
And then back to the presentation. Sorry, I'm not on my regular computer today, and I'm in I'm in a new location, so everything's a little unfamiliar to me.
So just real quick, in the link that I just shared in chat, the download to that widget is about halfway down the page, and that's where you can actually download that notebook and then upload it to your personal sandbox. And there's a bit more of an explanation on that link as well.
Right. Okay, so that brings us to the new thing, right? Which is the Geomad, right? And Geomad is not a geomedian. It uses a geomedian. And we're going to talk about that here in just a second. But Geomad stands for geometric median absolute deviation. And that's a mouthful. And so it's kind of nice that we shorten it to Geomad. But the idea is that, let's break this down. So the geometric median, right? It's basically doing kind of a similar thing. It's using a geometric median instead of an actual median because we are still in these higher dimensions. But when we're talking about the median absolute deviation, is that we pick some baseline and then we look at the deviation from these baselines, right? And we take the median of them, right? To get kind of a representative deviation. So I think, a good way, it's basically saying how much do these points vary around whatever I pick as my baseline. And for the Geomad, what we're picking for our baseline is that this that in this mathematical equation, the x with basically the tilde above it, this would be a geometric median absolute deviation for a two-dimensional set of data. We could have up to, again, 10 different things. So I wasn't, this was pulled from Wikipedia, and it would get very big if we tried to represent all 10 different things. But the idea is that we're using our geometric median as our baseline and then looking at the deviation from that point. And we're actually doing this in 3 different ways. And that's how these kind of colorful images here are generated. So there we go. There's actually 3 different types of distances that are being used, and each one of these is being mapped to RGB in order to kind of get, or you can map, you don't have to map them to RGB, but you can map them to RGB. But we can use the Euclidean distance, which is shortened to EMAD, the spectral distance, which is shortened to SMAD, and then the Bray-Curtis dissimilarity, which the Bray-Curtis dissimilarity is kind of, it's the difference over the sum, is basically what it is, of the spectrum. And so we can generate some really interesting images if we map those to RGB. So the Geomad uses the geometric median, but it's actually representing kind of the distribution of the observations around the geometric median instead of the geometric median itself. And I hope that may have cleared a few things up for some people if they were confused about the difference between the two. Because I know we kind of ran those 2 concepts together quite quickly, kind of at the beginning of last month. So, any questions?
So to summarize, Brian, Euclidean distance bad, geometric median good.
Well, no, Euclidean. Remember, the Euclidean distance is not bad because that's actually how we determine the geomedian, right? It's the point that minimizes the distance to all the other points, and we can use the Euclid. We can actually create we could use any sort of definition for distance that we wanted. But anyways, yes, that is a general 1-line summary, the TLDR, if you will.
So Brian, why is the the median deviation better, maybe in some cases, than just doing a median composite on some images, or is it?
Right. No, it definitely, like, it's displaying a different amount of information to you So let's say I have, I may have a data set that just has like, is just kind of noisy, right? Like the pixel is a little bit noisy in that it moves in the color space a little bit, right? But it may not actually move that much. That will generate if we generated a geomedian, it would be kind of, a general average, this is a type of average for all those pixels, and it would be kind of generally very similar to all the different things in the time series. But as we know, right, like vegetation is going to change quite a bit over time, and that it'll go, we could be going from very, very deep green to maybe some sort of soil color or something if all the vegetation dies back. And so the idea here is that the Geomad gives you kind of an idea of how representative, what the distribution around the geomedian is, right? So if there is a lot of change, or it basically kind of lets you visualize in a very real way, like what the spread is around. I put in the slide, I wrote in one of the slides that it's similar to thinking about the standard deviation around the mean, right? For a Gaussian distribution, the standard deviation will let you think about the distribution of data around the mean. The Geomad will let you think about the distribution of data, actually visualize the distribution of data around the geomedian. And so if there's a lot of change, you would get a single color from the geomedian, right? But the Geomad will be able to illustrate that there was a lot of change for generating a given geomedian, if that makes sense.
Yes, thank you.
Any other questions?
I do also want to point out again, for those of you who may not be using Geomad yet, that it is a fairly new product available on the sandbox. I think right now there's only the annual Geomedian available for 4 years, 2017, 2018, 19, and 20. It is possible to do, Brian, correct me if I'm wrong, it is possible to do the Geomad processing on the other platforms, though I don't think that there's inherently tools available on the sandbox yet to do that. However, there are tools to do the geomedians. So I think as support probably comes out a bit more, there might be some notebooks. Maybe this might be a good time to actually, start work on that to perform geomads on other platforms. But nevertheless, it's only available right now, actually with Sentinel-2 data for those 4 years on Sandbox annually, just so everyone knows. And also, Brian, are we gonna have time to get to the notebook on geomads and some of the issues that we faced with that? Was that in your timeline here?
Yeah, we can. I didn't really know how you wanted to talk about that. I guess that was something that was covered last time when I wasn't here.
We actually have not covered that yet. We can cover that.
Okay.
If you have some more slides, we can talk about that at the end. But I do want to cover that so people.
No, I'm finished. That's
use
my
it.
presentation. So.
All right. I guess that being said, maybe before we move to other things, are there any questions for Brian? All right, if not, I will take the floor for now. So interestingly enough, so Korea has been working to do some plotted changes on some coastal regions using geomads. And we found last week that the notebook actually does not seem to support NANs in the data very well. And when we talk about NANs, it's just simply a void in the data set. So even, I think the notebook even had issues, from a 2D perspective, if we just have, spatial position with one temporal slice and say 1 pixel of data missing in that image, The notebook was not able to handle that. So it would just return basically a blank plot, maybe some errors inside the notebook, and we couldn't use it. So on the existing examples, it would work fine, but when we put in our own extents, the notebook would break. So what we did is kind of go in. This is probably going to be changed in the coming weeks to reflect these issues. But in the meantime, I can share the notebook with the group after this discussion, so everyone has it in case they want to do geomads and have any issues. But I will kind of run through what we got. Let me share my screen. Can everyone hear me all right, by the way?
Yes.
Okay, great. Let me share my screen. All right, can everyone see my screen here? Brian knows, can you also see my screen?
Yes.
Yes.
Okay, great. Let me see here. I think I may actually have to pull it back up. Stand by. I think I was actually looking around in the original thing here. Let me upload the. So it's pretty much the same notebook, with the exception that we changed around a few things to accept nans in the data. So here we go. Open this. So again, this works on, it's a Sentinel-2 annual Geomad, and again, it only is available right now annually for 3 years, from 2017 to 2020. But this data coverage is all across Africa, including Madagascar, I believe, as well, off the coast there. But again, only for the 4 years. So generally speaking, this notebook is pretty simple. The main app is just Geomad. The packages necessary to run this are just the data cube, NumPy, matplotlib, and this plotting DEA Africa plotting tool. So we load up the app. We request a list of the products, and here it does say the annual low res. I think the low res might be available. If you look in Explorer, I think it does talk about the semi-annual product, but it is not currently functional. So it's only the annual, and I think the annual low res as well. We list our measurements here for the annual product, denoted as GM_S2_annual. We can see all of our measurements here for color, and also the SMAD, EMAD, BC MAD, which I believe are the main measurements oriented around the Geomad product. Here we load the data. So we call for our product, the measurements we want to see, the extent in X and Y for latitude and longitude, maximum dimensions of the plot there, the time. And currently, I think the way this sits, this does not allow us to do just like comma 2018 or whatever. There's a few other functions that we have to use to, if you want to do a composite, if you will, which is maybe mathematically not the greatest thing to do with a Geomad, or if you just want to do side-by-side plots. There's a couple other things you have to stitch in here. So right now it's only set up to display one plot. This is an RGB display from loaded data there. Then we call for the loading of the SMAD, EMAD, BC MAD. So here we just kind of make sure that we see what we're actually looking for with RGB image. This is where we actually load the Geomad measurements. And again, it's good to check these spots down here to make sure that you're actually loading the data if there's an issue with your customized extent. And here is where we ran into issues before in cell 8. So previously, all these functions here were only NP percentile in all these areas here. So the issue very basically is that these functions are they run into issues when there's no data points. So when we put in this NaN percentile, it kind of ignores the NaNs there and allows us to proceed with the plotting. That really is the only difference. Again, I'll share the notebook with everyone just so they have a functioning one just in case. But if you want to try this in the meantime, just the only thing to really note is in cell number 8, all we do is add NaN, N-A-N, to this np.percentile function here. And the other thing to note is that in this area here, it will, even with that NaN percentile, it's still going to give an error about this runtime warning, divide by 0 encountered in the log. It's really just a warning. Where I don't think, those maybe correct me if I'm wrong, but I don't think it's actually doing any divide by 0 issue like math here that's going to cause any sort of issue. It's just kind of warning based around the fact that there are NaNs. Is that right, Oz?
It is. So a NaN is essentially what you get when you divide by 0, right? Like if you divide by 0, but it's just some pixels have invalid values. So the logarithms that the algorithms internally taking are causing divide by 0 issues. But I think you're right. I think it can be ignored. It's just some pixels will be invalid.
Yeah. So other than that, here's a nice plot of an extent being looked at by one of the live session attendees. And just for example, so if we just want to maybe recreate this error so everyone can see here, if we take out the NaN percentile, and then let's just run this from scratch and make sure everything's still working. So we'll load our packages. Okay, connect to the data cube. Again, these are not errors. It's just returning some information here. So list our products. We got our products. List some measurements. We have our measurements. It's good. Loading the data for the RGB values. We're checking the RGB plot. Looks good. We're going to load the SMAD, EMAD, BCMAD measurements. Looks good. So right here, we're going to run cell 8. I don't think it makes an issue here on cell 8 or cell 9, but it's once we start trying to do the this math here in cell 12. Actually, no, I think it's in cell 16. Yeah, here we go. So right now, so then it returns a blank plot. In this case, it just says, nope, I'm not plotting that. There's no data in these X-rays, and it just kind of breaks. So then if we go back here and just type in NaN.
So Josh, if I'm understanding,
and this is
the version of the percentile function that's designed to deal with the NaNs in the data.
Yes, that seems to be the case. I think we'll try running it again just from cell 9. We may have to rerun the whole notebook. Let's have a look here, because
yeah. So there's often in NumPy there's often 2 different versions of some of the functions that are designed. So the percentile thing is actually a NumPy method. And there's often 2 different versions. One that just kind of does things regularly, and then the other one is sometimes you have to include a special version to handle NaNs, and it does things a little bit differently.
And this is possibly encountered in other areas in the sandbox. So I would say, Brian, do you think if there's an issue with NaNs, is it typically just not going to return a plot? Or in your experience, do you know if we'll see some other error return in a cell?
For not returning a plot, so it'll usually yell at you. it will usually throw a warning of some sort.
Interesting. So this seems to possibly be just in the Geomad notebook. Nevertheless, this is important for anyone wanting to plot other extents. This does not mean that every tile available on the sandbox necessarily has void data. There's certainly the base example, and just so everyone knows, I think it is in frequently used code. Let's double check here. No, it's in, I'm sorry, it's in
data sets.
Data sets, yeah. So the original notebook here is right here. Data sets under the root data sets, and then Geomad. So the inherent extent there seems to magically have no nans in it, so it'll run fine. Some areas may, but if you do encounter this issue, that is the fix. And again, I will share this notebook with everyone so they have it if they want to do some exploration with Geomad in their own areas. Other than that, I think that is it for me. Brian, I think you made a notebook kind of combining some additional plotting with the coastal erosion. What's another platform? Is that correct?
That's kind of a work in progress, but we can talk about the coastal erosion use case that Korea has been trying to work on. If that
Korea's okay with
that we wanna...
Yes.
Yeah, of course. And maybe you want to tell us a little bit about it, if you can, if your mic is working.
Korea, are you there?
Yeah, maybe I could explain on her behalf if she's not near a computer. So Korea has been working very well with some work, and she's also posted a question. So Korea, this question was to you to give us a background on your use case.
Yeah, thanks very much. Actually, we are working with coastal erosion, and we want to detect the changes for the years from 2013 to 2019. And we had this one by using the Landsat images. And again, we saw that no changes in these years. So then we plan to analyze the same use case, but to have maybe other data. For example, Sentinel-2, because Sentinel-2 has higher resolution than the Landsat images. So when this idea came, the team proposed to use the Geomad as an addition to this analysis. But after trying to do this, I had some challenges that I shared with you. So that's why actually I can say the team are very clever, and that's why they plan to share with us about the Geomad and Geomedian differences. And yes, now I understand what the difference between them. And also after having the meeting with Josh there, I mean, yesterday we had a meeting, and we saw that we don't need to have maybe Geomedian or Geomad for this one, because we just need to detect the changes. And actually we propose to use the Sentinel-2 data, so that I try to run the data. I try to run the use cases from notebook using those, I mean, both the Sentinel-2 and Landsat, and I saw some differences. I'm trying to share with you here, but unfortunately my internet is not very good indeed, so that I can't even load the sandbox here. Very sorry for that, but maybe Josh, you can share the notebook that I shared with you yesterday.
Yes, I got that on another computer, but let me download it and we can run that. Just a moment.
So I kind of was curious what you were seeing. So I went ahead and ran the coastal change notebook in the same area. And it doesn't look like when you run the coastal change notebook over that area, you know, over like the full extent, going all the way back to, let me see if I can.
Sorry, Brian. What I had experienced here is that I want to detect the changes from maybe 20,
Yes.
for example, 2017 to 2020, for example. But the problem is what I experienced here, the Geomad is not working with several years. It works annually, actually. So I can't detect the changes for the several years. It works only for 1 year.
Yeah. Let's see. I think that was, I shared the wrong window there.
And then in here still I have a question because the Geomad works with annually data. So are there any constraints in the number of images in the year maybe, or any images?
So,
and if yes, so what is the maximum number it can work efficiently?
right.
Maybe.
Good question. That's a good question. So when you're generating your own geomedians, right, there's not really a limit of like how many images you can compute. I mean, there's a limit to how many images you can compute based on like kind of like the computing resources you have. Like for instance, if you tried to do a geomedian over a really long span of time, this would take a very long time to process. The Geomad, though, as you point out, is a pre-computed product, right? And so they've done this for each year. They've done this annually. And so you're kind of, so if you want a Geomad, if you want one of those MAD products, either the EMAD, SMAD, or the BCMAD, you need you're actually kind of fixed in the period that you're looking at, which is a little bit unfortunate. So does that answer your question, or are you saying if you wanted to calculate your own? Because if you really want, so one of the go ahead.
But my question is there any constraints in the numbers of images per year? And I mean that, for example, if we have very few images in that year, so the Geomedian works maybe efficiently compared to when we have maybe many images, or it works the same, for example?
I think overall that the Geomad comprises a lot of images, probably as frequent as the Sentinel-2 data is available, because it's processing on top of the Sentinel-2 data. And if I'm not mistaken, it does comprise, you know, again, every image that is taken from that platform, course of all of those images acquired over the year. Does that answer your question? Inherently, I think with the Geomad, you know, there's, or Brian, do you have something?
Yeah, so I mean, I guess the limitations would be, right, is that you're stuck with whatever was captured during that year, and you can't change the extent at all because it's been pre-computed, right? So in order to calculate a geomedian, right, theoretically you only need like, you know, two captures, but like it gets better, and it's like kind of stronger. Like its strength is actually being able to summarize longer units of time. But the limitation on that is basically that it's kind of computationally intensive to generate, right? So the longer period of time you do, the more memory you'll need, the longer it will take to calculate. With the Geomad, it's kind of similar, because you have to, like, if you were going to calculate a Geomad from scratch, you first have to calculate a geomedian, and then you have to go back through and then do all the calculations for the deviation. Now, based on like what images you get, right, these are basically, you know, we're limited by the cloud cover and the, you know, kind of the different clear observations you get. So yeah, it's not really adjustable because it's pre-computed. But it's kind of, that's an advantage. It's nice that it's pre-computed, because it takes, like, if you were to try to calculate an annual period on your own, it would take significant computational resources and time, like, to do in a notebook, right? It would take, you know, many minutes to process. I ran the coastal change
again to re-summarize. I was just going to say again to just re-summarize. You know, I think, you know, that does point out, I mean, a big limitation with the Geomad is that you only have the annual data sets, you know, that which can be good, but if we're trying to do more, you know, analytical processes, or kind of explore more types of combinations of data or whatever, we don't have the capability to go in and look at segments of the Geomad, or really do anything else except look at the year in that regard.
So
Brian,
I was going to actually ask a question, which is, what type of temporal timescales are you looking at specifically?
Brian, sorry, can you repeat?
Yeah.
Sorry.
Go ahead. I was wondering, like, what kind of, so we're looking, so you're curious about coastal erosion, right? What type of time scale? So are you afraid that annual is too short or too long, or is it too short in that you're going to need multiple years, or is it too long in the sense that this is like very recent, like coastal erosion?
Actually, we are looking at the time series. And before we had Landsat, and Landsat for the DE Africa, you have the data from 2013. So before, I actually worked from 2013 to 2019. And after realizing I need to compare, I need to do the analysis by comparing the data. And I know that for the Sentinel-2, the data that are available in the sandbox are from 2017 to till now. So that I plan to change the time to starting from 2017 to 2020 for Landsat, and also the same years for the Sentinel-2.
and if I may,
So
Brian, if you let me share the screen here, I can show you her notebooks for what she did with Landsat Sentinel. And I think a lot of the issue too is just even in some small, a shorter range of dates, there just really is not much observable change, at least in this case. And I think it's inherently just due to the resolution and the fact that there's not much change happening. So I guess real quick, so this is, I think it was the Sentinel.
Sorry.
Actually, I'm sorry. This is the Landsat notebook that you made.
Right.
Yeah. What was that?
Yeah. From what I have in my mind, I can see that from 2017 to 2020, it doesn't have enough data to see the comparison there. So if there may be any way to use the same Landsat data, maybe to perform those maybe Geomad or Geomedian, so as to have the comparison. I mean, to have the comparison, yeah, for the same data, but different analysis. I mean, plain coastal erosion with the coastal erosion with the addition. I mean, plain coastal erosion and coastal erosion with the addition of Geomedian, but it's a rule answer.
I'm actually a little bit curious about the extents you've chosen. Is there something unique about the area we're looking at with regards to coastal erosion? Is this what is its relevance or importance to you? And maybe give us a little background on the area.
To maybe to see the changes, maybe to detect the changes in that area. And actually, I want to see the changes from maybe 2000 and maybe 2013 to till now, because it seems like in our country here, I can say in our cities, we need to preserve these coastal areas. And
Yes.
if that is the mission, so I just want to see what's the areas, I mean, what's the extent of the area that has been eroded in those maybe years, and what we are doing now so as to see our area preserved maybe.
Right. I guess I wasn't. I misphrased my question a little bit. I was kind of wondering. I'm not actually familiar with the area that we're looking at, and like, kind of, is this like a heavily populated area? Is this like a tourist area? Is this industry? Like, what is actually going on the ground in the area, and what is its history?
Tourists together with even I can say ourselves, we are building maybe the hotels and we are doing other activities, so that we are.
So these beaches are quite the attraction. Is what
yes.
Is what you're saying? People like to go on vacation there.
Mm-hmm.
Okay.
Yeah.
Okay.
If I may, just
yeah.
real quick, just showing real quick the differences between even the Landsat and the Sentinel processing with the Coastal Erosion Notebook. We can even see the resolution difference. So this is the Landsat. We can kind of see some resemblance of roads in here and buildings, perhaps. We go to Sentinel and it actually clears up quite a bit. And, I think the overall takeaway probably from this is that just given, in regards at least to this extent, I mean, I think that we may have some better ways to potentially visualize some of these changes, but analytically, I think that given the resolution of the platforms that we have, in some ways, it's good to see that there's little change, because given the tools that we have for the years that we have, we can see that there's very little change, and the takeaway ultimately is that there's not much erosion in the area. And we can get some idea on how little erosion there is, because these pathways in here are probably normal size roads for all intents and purposes. And if we compare that to the lines here out on the coast, it's probably the same width, if not less, which is a good thing. It means there's no erosion, especially over such a long time. That could be very good news for construction and things of that nature. But visualizing it in more detail is ultimately going to be better with higher resolution platforms like drone imagery or paid satellite data, which is a little bit of a different topic. But I did want to just show that comparison real quick from her notebooks that she ran, and kind of some of those takeaways. So Brian, I think you might have had something else to note. It is also time, so I want to be mindful of everyone's
close to time. Yeah.
But Brian, did you have any other high-level points?
Mine is to thank you guys for this support, at least from the participants, as much as we've taken all their time. Is that they have seen this story around here that we're able to present on the Sentinel Geomad. We have the use case from Korea, which we thank her very much for this opportunity to work with her as well. So it gives us an opportunity to work with anybody else who might propose a topic for next week. So the closing remark will be, what else do you want to see next week, our dear participants? In case anything comes to mind, you can always send me a message or reach out to us. We are connected everywhere. Some of you are on the DA Africa training group, and also you have my contact. Please feel free to connect with us. Mine is also to thank the presenters, Josh, Brian, and August. Actually, we've given them a thumbs up, just so they can see us clapping. Very grateful for this great presentation. Like in this classroom, you can actually see them. They're doing very, very good work. So as we part, we could turn our cameras on.